now rewriting mixed numbers as improper fractions. And then we're going to go the other way around. So I'm just going to start with an example, just to remind you how to do it. So as you're writing, just let me talk for a second. So when you have a mixed number, you can make it an improper fraction. And when you have an improper fraction, you can also make it a mixed number. You can go back and forth. And there's lots of reasons why you want to go back and forth as we go through different kind of problems. So we just need to practice how to do that. So my example is 5 2/7. I want to write it as an improper fraction. So how do I rewrite 5 2/7 as an improper fraction? Question mark. Okay, so you probably seen this before, or maybe you forgot. Here's what you do. Ready? I put it in color so it stands out again. You're going to multiply. Actually, I told you I wasn't going to use X anymore. I want to multiply 5 times 7, and then I'm going to add the 2. So when you do that, you get 5 times 7 is 35, plus 2 is 37. And this would become 37, and we keep the denominator. 37/7. That is now an improper fraction because the numerator is bigger than the denominator. That number is bigger than 1. So you take your denominator, you multiply it by the whole number, and then you add the numerator. And that's how you go from mixed to improper. So let's do a couple practice problems. So my directions would just be rewrite as an improper fraction. 1. Okay, 6 2/3. Multiply denominator times the whole number, add the numerator. So I would go 6 times 3 is 18, plus 2 is 20 out of 3. Denominator stays the same, 20 out of 3. You can even see it as a bigger than 1 because 20 out of 3 is way more than 3, right? So it's lots of 3s and 20, definitely bigger than 20. 2. 10 and 9/10. Multiply, add. So 10 times 10 is 100, plus 9 is 109/10, or 109 out of 10. Okay, I got 2 for you to try, 3 and 4. Okay, 3, 4 3/5, and 4, 9 2/3. Let me fix my 9. Okay, take a minute and give them a try and put them into improper fractions for me. Okay, so here we go. So you would have multiplied and added, And you should have gotten 23/5. How we do? We're doing good. Yay. Okay. And then multiply and add. And you get 9 times 3 is 27 plus 2, 29/3. I think they're sort of fun. Now, let's go backwards. That's sort of kind of the easier way, going from a mixed to an improper. Now we want to go from improper to a mixed. And just scoot down a little bit. Okay. So we're rewriting improper fractions as mixed numbers. This is just a little bit harder. I'm going to try to make it as easy as possible. I have like a cute little way of thinking about it. At least I think it's cute. You can tell me later on if you like it or not. Now, one way you can definitely use to rewrite improper fraction as a mix is using long division. I'm going to show you that. I honestly never use that ever, but I'm going to show you that as well. Actually, I'll show you that first, and then I'll show you my cute little way. Okay, so let's say I have 9/5. So this is my example. And I want to make it into a mixed number. Okay, so you can always do long division, and I'll show you what that means by long division. So how many 5s are into 9? 1. 1 times 5 is 5. I have 4 left over. So that tells me this number, if this number is less than this number, you are done, right? We're not going to do remainders, no remainders. We're going to go right to, we have this number is smaller than what you're dividing by, then you're done. Let me erase that so it doesn't look like a mess. Because your answer is right here. My answer is 1 whole, which is this number, the number on top, and I have 4 out of 5 left. So this is my whole number. That's my 1. And then I have 4/5, which is this number. So 9/5 becomes 1 4/5. Now, I don't really do it that way, only because I don't know. Again, I call it my cute little way. I don't know why, just a cute little way of doing it. So let's do it. Let me look how I would do it. Now, just because I do it this way and I think it's a cute little way, you might not even like it. So if you don't like it, you're going to use long division. Hey, here's my cute little way. It's all about words. So listen to what I say. So it's something like long division. How many 5s are in 9? I know there's 1. I can't do 2, that's 10, right? 1, 5, and 9. How many are left over? Well, if I take 5 away from 9, I have 4 left over. So that I have 4 out of 5 left. 1 4/5. So this is what I do. I take my denominator and ask, how many of that number do I have in my numerator? That's my whole number. And then I ask myself, how many are left? Well, the number left is your part over the whole of 5. So 4/5. And I'll show you more of that as I do more problems. All right, so let's practice. So 1, we're just going from improper to mixed. So let's say I have 62 out of 13. This is what I mean by bigger numbers. All right, so I could divide them if I wanted to, but I'm not going to. I'm going to go, okay. So how many 13s are in 63? Well, I don't know. So I'm going to try something. 13 times 5. 15, 65. Okay, that was 1 too many, right? So that means I have 12. Wow, what I write 12? How about I write the word 4? The number 4, which is what I meant to write. 4. So what is 13 times 4? 13 times 4 is 12, 52. All right, how many are left over? So 4 13s are 52, I have 62. That means I had 10 out of 13 left. That's my mixed number. Or you could have done the dividing way, which is perfectly fine. And you're going to sort of kind of do the same process. How many 13s? I would have found that had to be 4. That's 52. When I subtract them, I get 10. 10 is smaller than 13, so it'd be 4 and 10 over 13. So let me try a different one. Let's do 51 over 7. So that's improper. My numerator is bigger than my denominator, and I want to get to a mixed number. So I asked myself, how many 7s are in 51? Well, if I know my times tables, let's see, 7 times 7 is 49. So it has to be 7. And 49, how many are left over? 49, 50, 51, 2. 7 and 2 7ths. Or you could divide. 7 times 7 is 49. And there's 2 left over. 7 and 2 7ths. Either or. (23 over 8). Okay, let's see. How many 8s can I get out of 23? Well, 8 times 3 is 24. That's too many. So it has to be 2. No, how many is that? That's 16. So how many are left over? 16, 17, 18, 19, 20, 21, 22, 23. I think that's 7 left over. 2 and 7 8s. And we'll do one more, and that would be the end of this section, and we'll go on to the next section. Let's say we do 84 over 5. All right, so how many 5s are in 84? Well, definitely more than 10, because 10 times 5 is 50. So I might have to try something over here. So let's see. If I divide by 5, if I not divide by 5, how many 5s are in 84? So let's see. 15 times 5 is 75. And 15 times 6 is 90. So it definitely has to be 5. No, not what I want. 15 times 5. 50. Sorry, that's not what I wanted. I wanted 15 times 5 is 75. And then I wanted 16 times 5. Is that what I did? Yeah, that's what I did. Never mind, I was right. Take it back. I'm losing my mind. Okay, 15, because that was 75. How many are left over? I have 84. So 84 minus 75, that would just be 9 left over. And no, that's not right. I am losing my mind. Okay. Reset. Okay, 15 times 5 is 75. 15, yeah, I know. 16 times 5 was, okay, I put 90, it's 80. That would be the right answer. Okay, so 16 is 80 and 4/5. I did do it wrong the first time, even though I thought I did, and then I didn't, but I didn't. Like that. All right, that is 4-1. A lot to it, but it's just basic review. Hopefully for most of you, it's a basic review of fractions, especially if you haven't done them in a long time. Okay, any questions before we start? I like the dividing way. Yeah, some people like the dividing way, some people don't. That's why I want to show you both. Some people like my little short little cut, sometimes don't. Whatever works for you. Sometimes the short little way that I do is cute, and then when it's bigger numbers, you don't want to do that. You want to actually like divide it. So there's your both your ways. Okay. New section. 4.2. 4.2. Fractions, and I know we worked on this a little bit already, and simplest form. But there's a lot more to this than what it says. Okay, so our biggest goal coming up is that we are going to eventually we are going to, which I think starts next class, multiply, divide, add, and subtract fractions. Okay, so the skills here in this section will help us get ready for that. And that's why this section sort of seems like out of place for some reason. It's not just simplifying and simplest form. We just sort of talked about that already. It has that's the title of it. It also has a lot of different skills in it. The biggest one is prime factorization, which I'll show you what that means, but we're not really going to use it to really get to like adding, subtracting, and multiplying and dividing fractions a lot. But I definitely want to show you how to do your prime factorization. Okay, so few things first. Prime number. What is a prime number? A prime number is a number greater than 1 who can only, not who, that can only be divided by itself and 1. It has no other factors. There's nothing else can divide by. Example, 7 is a prime number because we can only divide 7 by 1 and 7 and nothing else. So some examples of prime numbers would be 2. I can only divide by 2 by 1 and 2. 3, I can only divide 3 by 1 and 3. 5, I can only divide by 1 and 5. 7 we talked about. How about 13? I can only divide it by 1 and 13. 19, I'm just giving you a couple examples. There's a whole bunch of prime numbers. If it's not a prime number, it's called a composite number. So these are numbers that are not prime. That's basically the way I can talk about it, which means I can divide them by many things. So I, or you, or we can divide these numbers by more than 1 and itself. Majority of our numbers that we know are composite numbers. A composite number would be 4 because I can divide it by 1 and 4 and 2 and 2, right? I can divide 10 by 1 and 10 and 2 and 5. I can divide 48 by a whole bunch of numbers beside 1 and 48, etc. So composite numbers are numbers that have a lot of different things they'll divide to make it simplified. So what we're going to do now is we're going to take some composite numbers and we're going to break them down into something called prime factorization. So prime factorization, this is our first skill for this chapter. Prime factorization. Okay, this is what we're gonna do. We're gonna take when a composite number is written as the product, okay, product meaning multiply, of its prime numbers. If you remember it, great. If not, we're going to do it all from scratch. Prime factorization comes in really handy when you have really big numbers, like really big numbers, because sometimes you can't break them down any other way but to think about its prime factorization. I actually want to start this on a new page, so to make sure I'm looking at you, to make sure you guys are all caught up with me. Everything's good. Okay. We look good. All right, so let's practice. So we are going to, these are directions, find each prime factorization. We're going to start with 56. All right, this is what you do. It doesn't matter what numbers you pick. Pick two numbers that multiply to be 56, not 1 and 56, because that won't get you anywhere. Anything else beside 1 and 56. Remember, it's a composite number, which means I can divide by lots of different numbers. I can divide by 2, I can divide by lots of things. But 56, I don't know about you, but the first thing that comes to my mind is the multiplication fact. 8 times 7 is 56. So I'm going to put 8 and 7. They're the two things that multiply to be 56. Now you can use, again, you can use anything, because at the end, we're all going to have the same answer. Now, 7's prime, I'm going to circle it, because 7 can only be divided by 1 and 7. There's nothing else. So our whole idea is that we're going to get to prime numbers. So when we get to a prime number, you stop. 8 is not prime. I can break it down more. I could break it down again. You could write anything that multiplies to be 8. I'm going to put 2 and 4. Now, 2 is also a prime, so I'm going to circle it. I highly suggest you circle. As you find your prime, circle it, and it'll keep you from getting lost. 2 is a prime. I can only divide by 2 and 1, 2. So 4 is not. I can break 4 down to 2 times 2. Now, they are both prime. I have everything into broken down to primes. I'm done my prime factorization. That's what this is called breaking them down into primes. It's called factorizing to primes. So now I just have to write my answer. So the answer is everything you circled is your answer, but I am not going to put, remember, it's multiplying. I am not going to put 2 times 2 times 2 times 7, because prime factorization wants the shortest method. So how many 2's do I have? I had 3 2's. 2 to the 3rd times 7. That is my answer. You always use exponents if you have more than one of the same number. And if you don't get it yet, that's all right. We're going to do a whole bunch of problems. Just sort of let it sink in a little bit. I took 56. I divided it by something that I knew it would divide by, not itself in 1. And I kept going until I got all prime numbers. And then I wrote it as a prime factorization, as multiplying. 2. Let's try 72. All right, so, okay, I can't think of anything. I mean, I can, but I'm going to 10 on that. I do know I can divide it by 2. Okay, so I'm going to break that 2 in something. So 2, and if I divide 72 in half, I get 36. Well, 2 is prime. And remember, you can start anything you wanted. Like I would have probably started 9 times 8, 72, right? And then going from there. But you can start any way you want. It doesn't matter where you start as long as it multiplies to be 72. Now, 36 is definitely, I can break down. I know I can go to 6 times 6. Neither of them is prime, so I'm not even going to circle them. I could have gone to 9 times 4. There's more than one way to go. Now I'm going to take 6, and I know 6 is 2 times 3. Now, aren't they both primes? Yes, because 2 times 1 is 2, or 2 can only be divided by 2 and 1, and 3 can only be divided by 3 and 1, which means this also has a 2 and a 3 as well. And I have all primes. I have nothing left. I haven't done prime. So now I can write it in prime factorization. And I'm going to go, how many 2's do I have? 1, 2, 3. I have 3 2's times, how many 3's do I have? 2, 3 squared. That's my prime factorization. Great. Any questions before I do some more?
I was gonna say you can go what 9 and 8, and then break the 8.
Right. That's what I said.
Which
You
will
don't
give
have to
you more.
do, right. You don't have to do 2 and 36. You could do 9 and 8, and you're still going to get the same answer at the end. You want me to show you that too? So
Yes, ma'am.
if I do 9 and 8, which is fine, then 9 can be broken down to 3 and 3, which that is also my primes, right? And then 4 can be broken down, 8, sorry, we broke down to 4 and 2. Well, 2 is my prime. And then 4 I can break down to 2 and 2, and there's 2 more of my primes. And you'll notice I have the same answer. I have 3 2's, 2 to the third, and I have 2 3's, 3 squared. So it doesn't matter, that's what I mean. It doesn't matter what you pick to divide or break down that number to, you're going to get the same answer at the end because you're breaking down the primes, and the primes are always going to be the same no matter what multiplication factor you use. And by the way, I should have mentioned that these should be the prime answers, my circled answers should be written in numerical order, smallest number to biggest number. That's why I put 2 to the third times 7 the way I wrote it. 2 is smaller than 7, so 2 to the third goes first. And the same thing with 2 and 3. 2 is smaller than 3, so 2 to the third times 3 squared. I don't think the program that you use is going to mark anything wrong if you do it opposite, but a common practice in math is to put them into numerical order. So let's try 80. Again, lots of things. I can break 80 down. I'm just going to start with 8 and 10. It's the first thing I see. And that's what you should do. Start with the first thing you see. Neither of them are prime. So we're going to break down 8 to 4 and 2, which 2 is my prime. And then I'm going to break 4 down to 2 and 2, which are my other 2 primes. And now I can go to 10 and I can break that down to 5 and 2. Well, guess what? They're both prime, 5 and 2. And now I can write my answer, and I'm going to go 2's first. How many 2's do I have? I have 1, 2, 3, 4. I have 2 to the fourth times how many 5's do I have? 1. 2 to the fourth times 5. I want to give you guys one. Oh, yeah, you could do really big numbers with prime numbers too. But they can get very, very tedious. It's the same thing. Let's say, let me do a bigger number. Let's say I do 250. It's the same idea. It's just a bigger number. But I suggest you go to something not too hard when you do these. Okay, what if, I have a question for somebody. What if you only have like 4 times 5 times 6 with no exponent? That's fine, except 4 is not a prime. So let me go down here for a second. I'm going to erase this. So let's say you do all this work and they only have one of each, right? Say it's 2 times 5 times 7. That's fine. That's a perfect answer. All primes. They're all to the first power. We don't write 1. So you don't have to have an exponent if the answers that have exponents, if you know what I mean. Just make sure that all the numbers you have for an answer are prime. Okay, so let's do 250. Now, I don't know the first thing you guys see, but I see 25 times 10. You could do 50 times 5. It doesn't matter. Doesn't matter. Whatever you do, eventually you get the same answer. So 25 breaks down to, oh, actually, this is a big number. It's sort of nice. 5 times 5, that's just, they're both prime. And 10 breaks down to 5 and 2, and they're both prime. That was actually nice. For a kind of big number, it's sort of nice. So my answer would be 2 times 5 to the third. All right, questions. They're sort of kind of fun once you really get them. If that makes any sense. All right, so last section we talked about how to simplify fractions, and we'll just do a little review. I know we just talked about it, but I'm going to do something in a second, so why I have to mention it. Simplifying fractions. Yeah, so let's do like just a little mini review. So let's say I have 48 over 64. A little bit bigger number we did last time. We did smaller numbers. All right, we want to simplify this to something that's totally simplified, nothing left. I know that I can divide both of them by 4. If not, if you don't see 4, you can divide each of them by 2 and keep going. I don't know if it's the simplest way to do it, but I'm going to divide both of them by 4. Let me see what I have left. All right, so if I divide 48 by 4, I'll do my work over here. I get 1. And I bring down my 8, I get 2. So that's 12. If I divide 64 by 4, I get 1 4, which is 4, which is a 2. And I bring down my 4, and that's a 6. 12 over 16. But is that simplest form? No. I can then divide each of them by 3. Nope, 2. 2. 2. Half of 12 divided by 2 is 6. 16 divided by 2 is 8. And I could do one more. This is what I talked about before. Keep going till you can't go anymore.
Not divide it by 4.
Say it again.
Did you not divide that by 4 again?
No, yeah, you can. You can. I actually was going to, but I wanted to like do the long way just to show you how you can keep going till you get the answer. That's why I changed my mind. I was going to do 3, which doesn't work, but I was going to do 4, but I want to do this way. But yes, absolutely. Honestly, the best thing to do would divide it by 16. That's the easiest way. But okay, 6 divided by 2 is 3. 8 divided by 2 is 4. And I know that I am done. So what I wanted to show you is you can do more than one dividing to get to your answer. It doesn't matter. Or if you know what to divide by 16, you have your answer right away. 48 divided by 64. Now, not a lot of people see that you can divide by 16. That's why I wanted to show you how you can just keep going till you get an answer. That would be 3, and that would be 4. So one step, I could have the answer, but I wanted to show you different stages, different steps, if you had to. Now, that was like last section that we just did. I'm going to add something. We're going to add variables. Oops. To our fractions. That's our new thing for this section. So for instance, we are going to simplify these. So we're going to have a number, a fraction that's a number, and we're also going to add X, Y, Z's and whatever else we have. Okay, so simplify. we are going to do, I'm going to start with a small one. 8/10 x. So we have two x's and we have 8/10. Now I'm all about doing it pieces. I'm all about doing parts. Don't look at it as 8x divided by 10. Think of it 8/10. That's one part. X divided by x is another part. So almost think separate. Do one at a time. So 8/10, I could divide both of them by 2. So 8/10, I can divide both of them by 2. And I get 4/5. So I know so far I have 4/5. Now, what is x divided by x? Well, just like any number, what is 5 divided by, 5? 1. What is 10 divided by 10? 1. So what is x divided by x? Is just 1. So basically, we don't need them anymore. It becomes 1 because what is 4/5 times 1? Nothing, 4/5. So they, what I call, undo each other. Which means we don't need them anymore. The x's are gone. They undid each other. They took each other out. We don't need them anymore. My answer is just 4/5. So when you have a fraction, actually, I'm going to explain it more in the next one. Next one, I can really explain it much better. So let's say I have 7x to the third over 56x squared. This is when I can really explain what I wanted to explain before. So we're going to think separate, right? Separate. Okay, so actually, we're not going to think separate. I'm going to show you something else. Let's do a prime factorization. Let's do it without thinking about primes. Let's think about primes for a second. Hold on. 7 is a prime. I can't simplify 7 anymore. I'm going to write out x. We're going to go backwards. I have 3 x's times x times x times x. That's what I have. I have 3 x's. I'm not even going to do prime factorization. I'm going to do opposite. Okay, 56 is 8 times 7. Why did I pick 8 times 7? Because my 7s are going to cancel or undo each other. And I have x times x. I have 2 x's. So numbers first. I don't need 7 divided by 7. That's just 1. So I know my 8 is going to be in the denominator. I don't have any number left in my numerator. Now you want to look at the x's 1 for 1. So if you go 1 for 1, I don't need those 2. I don't need those 2. I am left with 1x. I was left with an 8 in the bottom and an x on the top. So my x stays in my numerator and my 8 stays in my denominator, and that is the answer. Why 1 for 1 of the x's? Because x divided by x is 1. 7 divided by 7 is 1. I don't need them anymore because 1 times anything is anything. I don't need anymore. They undo each other. I don't need them into my problem anymore because it became 1, a multiplication of 1. I don't need it. Three y squared over 90 y to the 4th. Okay, I can think this 2 different ways. Like the last one, I could have thought 2 different ways too. I can divide both of them by 3 if I wanted to, and I would get 1 over 30, which means I have a 30 in the denominator and I have a 1 in my numerator. I don't think I need my 1, but I'm going to write it there for right now. Or I could have done this 3 and broken this down to 30 times 3. Why would I do that? Because I know I can get rid of my 3. Either or, there's two different ways to think about how to do this problem. But y's, I have two y's. I'll do it two different ways. And I have four y's. 1, 2, 3, 4. 1 for 1, I'm going to take my y's away. Whoops, 1, 2, 3, 4. 1 for 1, I take my y's away. And then my answer, whether I do the top or bottom, is going to be, look, there is nothing left in the top except 1. 1, there's nothing less in the top, which means it's 1 over 30, 30, 30, and I have two y's left, y squared.